Section 6.2 deals with trigonometric functions of angles and finding exact values in a triangle. So here we have a right triangle, and in this right triangle, this side is called the hypotenuse. The other two sides, based off of what angle you're dealing with. If you're dealing with that angle, this side would be considered the opposite. This side would be considered the adjacent. And if you're dealing with this angle, then here is opposite, and here is adjacent. And in any right triangle, there is this Pythagorean theorem, which says a squared plus b squared equals c squared. So if you're trying to find something, one of the lengths of the sides, you can use the Pythagorean theorem to find it if you know the other two. Well, if you know an angle in some of the sides, then you have to use the trigonometric ratios to figure those out. Now these first ones, sine of theta, cosine of theta, and tangent of theta, are three that you probably are familiar with from geometry. The other three, cosecant, secant, and cotangent, are similar to sine, cosine, and tangent. So let's go through them. Sine of an angle is the ratio of the opposite side over the hypotenuse. Cosine of an angle is the adjacent side over the hypotenuse. And tangent is the opposite over the adjacent. And from your days in geometry, you were probably told this word. SOHCAHTOA. That keeps everything straight for you. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. These other ratios, cosecant is the reciprocal of sine, so it would be the hypotenuse over the opposite. Secant is the reciprocal of cosine, which then is the hypotenuse over the adjacent. And cotangent is the reciprocal of tangent, so it is adjacent over opposite. So here we have a right triangle. 5 and 8 are the lengths of the sides, so we have to try to find the hypotenuse. So that would be 5 squared plus 8 squared equals h squared. And 5 squared is 25, and 8 squared is 64, so 89. The square root of 89 is h. And so the ratio for the angle, if this is the angle that we're dealing with, sine would be 8 over the square root of 89. And then you can simplify that to 8 times the square root of 89 over 89. Cosecant is the reciprocal of sine, or hypotenuse over opposite, so square root of 89 over 8. Cosine is adjacent over hypotenuse. So it's 5 over the square root of 89, which turns into 5 times square root of 89 over 89. And secant is the reciprocal of that, so it's the square root of 89 over 5. Tangent would be 8 over 5. And cotangent is the reciprocal, so 5 over 8. And that is how you will use those trig ratios to write the exact values for sine, cosine, tangent, cosecant, secant, and cotangent. Now, there are some special angles that you should recall from your days of geometry. These are the 3. Because if you have a triangle, and this is 30 degrees, well then this is 60. And if you recall things about a right triangle that's a 30, 60, 90 triangle, it would be if this is x, this is 2x, and this is the square root of 3 times x. And it doesn't matter what x happens to be, so like if that's 1, then that is 2, and that is the square root of 3. So in any right triangle, that is a 30, 60, 90, sine of a 30-degree angle is 1 over 2, or 1/2, which makes cosecant 2 over 1, or just 2. Cosine of a 30-degree angle is the square root of 3 over 2. And secant is 2 over the square root of 3, which then turns into 2 square root of 3 over 3. And tangent is 1 over the square root of 3, which would turn into the square root of 3 over 3. And cotangent is the square root of 3. Now then, you can also use this triangle to figure out the 60-degree angle. So 60-degree angle, sine is the square root of 3 over 2. It's the same as the cosine of a 30. And if cosine is 6 of 60 is the square root of 3 over 2, cosecant is 2 over the square root of 3. Cosine of a 60-degree angle would be 1/2. And secant then is 2. And tangent is the square root of 3. And cotangent then would be 1 over the square root of 3 or square root of 3 over 3. Now, as you look at these, the sine of a 30 is the same as a cosine of 60. These two angles add up to 90 degrees. So anytime you have angles that add up to 90 degrees, complementary angles, the sine of one angle is the same as the cosine of the other. And then the tangents are the reciprocals of each other. All right, then our 45 triangle is like so, where both those angles are 45 degrees. And if that is x and that is x, this is the square root of 2 times x. So if this is 1, that is 1, and then that is square root of 2, because 1 squared plus 1 squared equals 2, and the square root of 2 then is the hypotenuse. So our sine will be 1 over the square root of 2, which is the square root of 2 over 2. And cosecant is the reciprocal of that, so the square root of 2. Cosine is going to be the same thing, because, hey, those are total 90 degrees, so the sine of the angle is the same as the cosine of 90 minus it. And that makes secant square root of 2. The tangent then is 1 over 1, and the reciprocal of 1 is 1. These angles here are important in finding exact values, especially of angles that are of this nature, but also in your circle, because here's a 30-degree angle, there's a 45-degree angle, and there's a 60-degree angle. Well, if you reflect this over here, then you have that angle, which is the same as this one, and if you reflect it down, that angle would be the same as that one and that one as well. They have the same properties of sine, cosine, and tangent. Same with this one reflected over here, which if you extend the line gets you those. Those are all the same. And here's this angle, and then you have that angle, and then this one here as well, where that's 30 and this is 30 and that's 30 and that's 30. They have the same properties for sine, cosine, tangent, secant, cosecant, and cotangent as well. Give or take the sign, positive or negative. And we'll get into that in our next section. Now, another way to look at the ratios would be on a coordinate plane with a circle. So if we have a circle, then this point here is your radius. Okay, well, if we, let's see here, make a triangle with the x-axis being a side, so like that angle right there, and here's our right angle. This is the hypotenuse, which is also the radius of the circle. And then if you're talking about this angle here, this would be opposite, this would be adjacent, and so sine is opposite over adjacent, or hypotenuse. Well, the opposite side is this coordinate here, that coordinate there, which is x comma y. Well, the opposite side is your y value, so sine is the y value over the radius, which then makes cosecant the radius over y. And cosine, which is this, it would be adjacent over hypotenuse, and then the adjacent part is your x value, so it's x over the radius, which makes secant the radius over x. And tangent is opposite over adjacent, which opposite is y, adjacent is x. So it's y over x, and cotangent is x over y. So in this example here, we have 2, negative 5. So 1, 2. So this is our triangle. And that is the angle you're dealing with. And the circle would be center. That's the radius. And then it goes like so. This right here in our triangle, from here to there, that's 2. From there to there, that is 5. And it's negative because we're in the third quadrant. So then sine of theta, which is that angle right there, would be a negative 5 over, and now we have to do some calculation to figure out what the radius is. So 2 squared plus 5 squared equals r squared. That's 425, so square root of 29 is r. Even if that's a negative, it's going to be that. So sine is negative 5 over the square root of 29, which turns into negative 5 square root of 29 over 29. And if that is the case, then cosecant is the opposite of the square root of 29 over 5. Cosine is going to be adjacent, which is 2 over the square root of 29, or 2 square root of 29 over 29. And cosecant, then secant is going to be the square root of 29 over 2. Finally, tangent of theta is a negative 5 over 2. And that makes cotangent negative 2/5. And anytime you're doing one of these with a coordinate, you always have to have a side being part of the x-axis. So if you had a coordinate, say, of negative 3, 4, 1, 2, 3, 1, 2, 3, 4, right there's your coordinate. The triangle you're actually talking about is this one, which you're figuring out this here, but you're also worrying about that angle, because in this quadrant, let's see, cosine would be a negative 3 over, excuse me, sorry about that, 3 over 5, and sine would be 4/5, because if this is a 3 and that's a 4, 3 squared and 4 squared is 25, and that makes that 5. And then tangent would be a negative 4 over 3. And then cosine would be, or secant, would be a negative 5/3. Cosecant is 5/4, and cotangent negative 3/4. And that is everything for section 6.2.